Hello and welcome back, guys. So, for today, we will move on to the new chapter, which is molecules of life, in the new subtopic, which is water, or usually we call it as an aqua. Moving on to the next slide, we see the structures of water. Cute, isn't it? Okay. Water consists of one oxygen atom and two hydrogen atoms. Three atoms form a triangle shape and we can call it as a V shape. The hydrogen atoms are 104.5 degrees from each other. The bond that links hydrogen atoms and oxygen atoms within water molecule is called covalent bond. Water is a polar molecule and it carries unequal distributions of electrical charge. We have two oxygen atoms which has a partially negative charge region, and we show it or we write it as 2 as negative. And we have one hydrogen atom which has a partially positively charged region, and we write it as positive. Clear? If you have any question, you can just write on the comment down below. Alright, next. The partially positive hydrogens of one molecule is attracted to the partially negative oxygens of a nearby molecule. The bond that links hydrogen atoms and oxygen atom between water molecules is called hydrogen bond. One water molecule can form hydrogen bonds with maximum 4 water molecules, and we call it as a tetrahedral. So hydrogen bonds are weaker, but they are strong enough to hold water molecule all together. The hydrogen bond form, break, and reform with great frequency. And we can see in the pictures given, the hydrogen bonds is the dotted line. The extraordinary properties of water emerge from this hydrogen bonding, which organize water molecules into higher levels of structural order. Note that oxygen atom is partially negative to S minus, hydrogen atom is partially positive S positive. They are triangles 104.5 degrees to each other, have a covalent bond, hydrogen bond, and they are called as a tetrahedral. Alright, next. Before we're moving on to the properties of water and its importance, we need to know that hydrogen bonding between water molecules is the basis for water's properties, which largely account for the unique properties of water. Alright? Put it in your notes so you can always understand about water and its property. So firstly, the properties of water, is the polar molecule, or we call it as a universal solvent. Due to unequal distributions of charge in water molecules, and hydrogen atoms is partially positive charge and oxygen atom is partially negative charge. So water molecules are able to surround ions and polar molecules. And water has the ability to form hydrogen bonds with other molecules. Secondly, is the law of viscosity. Viscosity is the measures of a fluid inability to flow or the measures of internal resistance to flow. Less viscous the fluid, the easier it can flow or move. Water has a low viscosity due to the hydrogen bonds that between water molecules that constantly form, break, and reform. Water molecules can flow easily with less friction through narrow tunnels such blood capillaries or xylems. Third is the high specific heat capacity. The specific heat capacity of water is defined as the amount of heat that must be absorbed or lost for 1 gram of that water to change its temperatures by 1 Celsius. So the heat capacities of water is 1 calorie per gram and per degree Celsius, abbreviated as 1 cal over gram Celsius or 4.2 joule over gram Celsius. Due to extensive hydrogen bonding between water molecules, large amount of energy needed to break or to form the hydrogen bonds between water molecules. Water will change its temperature less than other liquids when it absorbs or loses a given amount of heat. You get it? Alright. For the importance of the polar molecules or universal solvent. Firstly, water acts as a universal solvent or a versatile solvent. It's able to dissolve many ionic substances, many polar substances, and many hydrophilic substances with a positive or negative charges. For example, natrium chloride and sugar. It's able to dissolve charged particles by surround the surrounding charged particles, forming hydration or solvation shell. The partially negative charged oxygen surround cation and partially positive charged hydrogen surround anion. The sphere of water molecules around each dissolved ion is called a hydration shell. So we have the two compounds, which is ionic compound and polar compound. Ionic compound is made up of ions, which is anions and cations. For example, we have the natrium chloride. Natrium Na+ and chloride Cl-. For polar compound is made up of molecules that have different charges at each end. For example, we have sugar, we have vinegar. So even molecules as large as protein can dissolve in water if they have ionic and polar regions on their surface. So water repels non-polar molecules or hydrophobic or water-insoluble substance. For example, lipid, fats, and oil. The hydrocarbons compound. Next, water is a medium for chemical reactions to take place. In addition, hydrolysis and condensation. Furthermore, it is a medium of transport in organisms, and also many different kinds of polar compounds are dissolved along with ions in the water of such biological fluid as blood, the sap of plants, and the liquid within all cells. Get it? I hope it's crystal clear. Alright, for the low viscosity, it is important to its cellular motion, the movement of organelles, to aid circulatory system, blood flow throughout the body, and act as a lubricant to reduce friction. For example, the mucus, the saliva, the synovial fluids, and pericardial fluid. And lastly, to aid in the movement of certain organisms such as earthworms, snails, and slugs. Next, for the high specific heat capacity, it is important to help organisms maintain their body temperature. Because organisms are made primarily of water, they are better able to resist changes in their own temperature. And it can also help moderate Earth's climate, stabilize ocean temperature, moderate air temperatures in coastal areas, and also creating a favorable environment for marine life. And it can be used as a coolant for radiator in car engines, which we are usually use. Air conditioner. Moving on to the fourth point for the properties of water is the high latent heat of vaporization. So heat of vaporization is the quantities of heat a liquid must absorb for 1 gram of it to be converted from the liquid to the gaseous state. To evaporate 1 gram of water at 25 Celsius, it is about 580 cal of heat is needed. Then a lot of heat energy needed to break the hydrogen bonds between water molecules to change water into water vapor. Next, for the fifth properties, the high surface tension. Surface tension is measure of how difficult to stretch or break the surface of a liquid. Tendency of water surface to resist being broken. And due to cohesion between water molecules, hydrogen bonds hold water molecules together, and we need to resulting from the collective strength of hydrogen bonds. Last but not least, the maximum density at 4 Celsius. Water becomes less dense as a solid than as a liquid. In other words, ice floats on light liquid, or ice floats on a liquid water. Water reaches greatest densities at 4 Celsius, which molecules of water have a fewer hydrogen bonds, allowing them to slide closer together. At 0°C, water molecules become locked into a crystalline lattice, each water molecule hydrogen bonded to 4 other water molecules. So hydrogen bonds keep the molecules at an arm's length far apart to make the ice about 10% less dense, which is 10% fewer molecules in the same volume than liquid water at 4°C. Water becomes less dense upon freezing, and in ice, water becomes locked in a crystalline lattice. The hydrogen bonds keep the water molecules far apart to make ice less dense. For the importance of high latent heat of vaporization is evaporative cooling effect. Then, the sweating gives cooling effect because large amount of body heat is absorbed by sweat. The heat energy released when steam condenses into liquid on the skin. Evaporative cooling of water contributes to the stability of temperature in lakes and ponds that prevent the terrestrial organisms from overheating. On a global scale, it helps moderate Earth's climate. Solar heat absorbed by tropical seas, evaporation of surface water, then it releases heat as it condenses and forms rain. For the high surface tension, the importance is to allow water to hold up substance heavier and denser than itself. For example, water strider, rough spider to work on the surface of a pond or water. Water transport in plants because of the properties of cohesion and adhesion. Cohesion due to the hydrogen bonds between water molecules. It helps to hold together the columns of water within the cells or the xylem. And for the maximum density at 4°C, it is important because floating ice insulates the liquid below, preventing it from freezing and allowing aquatic life to exist under the frozen surface. Lastly, this is for the water has a strong cohesive and adhesive forces. What is cohesive? Cohesive, or we know as a cohesion, is the attraction between water molecules, while adhesive, or we know as the adhesion, is the attraction between water molecules and another water molecules. So the importance of these forces is for capillary action, which is water and dissolved nutrient can move up a narrow tube or xylem. For example, water move up the xylem vessel and blood move in capillaries. Alright, I think that's all for today. We have done with this chapter, or we have done with this subtopic, which is water. Don't forget to subscribe and like. See you in the next video. Stay tuned.